Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, day 10 of April challenge. So the problem is valid parentheses. What the problem says is we get a string that contains both an open parentheses, it can contain a closed one, and different types of parentheses, right? And we want to determine if it's valid or not, right? And by valid, they mean every open bracket must be closed by the same type. So if we have an open parenthesis like this one, we should have a closed one. If we have it like this, we should have a closed one like this. And that's the idea, right? And it must be in the correct order, which basically means you shouldn't have this one first and then the open one second, right? That doesn't make sense. And so, for example, if you take a look at this one is valid because we have an open parenthesis and then we have a closed one. So true. This one valid as well because each one has an open and a close. This one is not because we have an open, but we have a different type of parentheses closed. And so we should return false here. And we are guaranteed that the string contains only these parentheses. It doesn't contain any other character. Okay, so how do we handle this? Okay, so let's take a look how we can handle it. So usually with this type of valid parentheses or a balanced parentheses problem, we usually try to approach them with either a stack, right? Which basically means when we encounter an open parentheses, we push it, and then when we encounter a closed one, we pop out the stack. And if the top of the stack doesn't match the closed parentheses, which means basically for something like this, we don't have the top is not this, then we know there is a mismatch. Okay, so with that stack approach, let's actually try it on some examples and see if it will work. So what do we need? Well, we still will do the usual approach, which is if the string is an open bracket, we will push it to our stack. So let's apply it to this example here. So our stack is like this, and let's just move this a little bit down so that we can have some space. Now, if the string is opened, we will push it to our stack. If it's closed, what should we do? So if string is open, let's push it to our stack. And then when we move, so this would be our stack here, we have a closed parenthesis. What should we do? Well, it depends. Now, there is some case where we start out with a closed parenthesis. So in that case, our stack would be empty. And so what should we do? Well, this means we already know it's invalid because there is no matching open parentheses. So in this case, we can just return false. So basically, if the string is a closed parentheses, then we can, and the stack is not is empty, right? So stack empty, then we know we should return false because this is not a valid case, okay? Now, otherwise here, when we encounter a closed parenthesis, we just need to check the opening of the stack if it matches. Now, in what case would so this case, for example, open like this and then this one should not work because this is closed but doesn't match this one. So we need some way to identify that for this open, we need exactly this one. And for this open bracket like this, we need exactly this one. So how do we do that? Well, we can just use a dictionary. We can use a map like this. So let's call it we can call it D. And so we just say that open like this matches with this one. And then open like this matches with this one. And then open like this matches with this one. That way it's really easy to tell for all of them instead of just having multiple if and else. And now it's easy to check. We can just check that if it's closed like this, if it's not an open parenthesis, how do we check open? Well, we can just check that it's in the keys because the keys here are all open parentheses. Okay, so if C in D, we know it's open parentheses, right? We can do some treatment. Now, what about the else case? The else case means it's closed parentheses. So in case of closed, we can do the first check that it's we can check if the stack is empty, then we can return false. So we can do if not stack, we can just return false because we know we have closed and we don't have a matching one. Now, in a case, how do we handle the case where we encounter a closed like this, but the stack has an open like this? And so for that one, we can just check if we can just check if the top of the stack, the value for, so we can just check the value for this, the top of the stack, which is an open parenthesis. So the top of the stack can be just obtained with -1. And so that will give us the corresponding matching closed parentheses. If that's different than the character we have, which is the closed parentheses, then that means it doesn't match. So that means we are in a case like this, where the top of the stack needs this one, but we found a different one like this, which is C. And so in that case, we also return false, because that means there is no match. Okay? Now, otherwise, so this is else if. Otherwise, this means we have a closed parenthesis, but it does match because we skip it. This one wasn't true. So in that case, we should just pop it. In this case, we should just pop the closed parentheses. And so we can just do stack.pop. Okay? And so let's continue applied. So we have it, we move. We encounter an open, we add it. We encounter a closed, we check if it matches. Does it match? It does match. It does match this one. And so we pop it off and we move again here and we add it and then we move and we check, does this match the corresponding one for the one in our stack? It does. And so we pop it. And now at the end, we want our stack to be empty, because let's say we had something like this, right? Then this is invalid because our stack is not empty. So we want to, at the end, we want to just return whether our stack is empty or not. So we want to return whether the length of our stack is equal to 0 or not, right? And this should handle all cases, because it does handle first the fact that every open parenthesis gets closed, because at the end we check that our stack is not empty. At the end we check that our stack is empty. And it does also handle that every open parenthesis is followed by a closed parenthesis that matches it with this check that we do here, right? And so with that, we should be able to solve it. So let's just implement the solution and make sure it passes. Okay, so let's implement the solution we just saw in the overview. So what do we need? Okay, so first, we just need to check, we just need to go through our string, right? But we also need the matching dictionary that just says that this one maps to this one, and this one maps to this one, right? Just every parenthesis with open and close. And this one matches with this one, right? And then we can just go through this. Now, if C is in D, that means it's in the keys, so it's one of the open parentheses. You could also, if you want, just do keys like this, but that's not necessary here. You could just do like that. Now, this means it's open. It's an open parenthesis, and so in that case, we just want to add it to our stack, so we need to define our stack. Okay. Otherwise, right, we want to check if it's valid or not. So first we want to check if not stack, which means basically that we have a closed parenthesis, right? But our stack is empty. And so in that case, we want to return false immediately, because that means it's not valid. Now, otherwise, we know the stack is not empty. We want to check if the top of the stack, which would be an open parenthesis, because that's what we add, we want to check if the closed one that matches it is actually the value of C, because if that's not the case, that means we have a problem. Now, if it's not the case, which means different, then we want to return false, because that means we have in the stack something maybe like this, but C is equal maybe to this one, right? So that's what we do here. And then otherwise, what should we do? Otherwise, that means C matches actually. That means if the top of the stack was this, that means C actually matches with a closed one. And so in that case, we should just pop it because it matches, so we should just pop. Okay? And now at the end, if we go through all of them and we only want to make sure that we are not in a case like this, where in that case, our stack will not be empty. And so we want to check here, return that the length of our stack is actually equal to 0 for this string to be valid. And that should be it. So let's run this. Let's submit. And that passes. Now we can simplify this slightly because we can just say not stack or this, right? No need for 2 checks. And so this should work. Yeah, and that's pretty much it. Now in terms of time complexity here, this is O of n time because we traverse just once. In terms of space, we are using this one, which is this one constant because we only are using 3 entries. Stack is O of n because in the worst case, we may have a string like this, like with only open parentheses, like that. And so it's O of n space as well. Yeah, so that's pretty much it for this problem. Please like and subscribe and see you on the next one. Bye.